Welcome to section 5.5. Our objectives are I can write indirect proofs and I can apply inequalities in one triangle. Indirect proofs are kind of weird. You take the proof and you assume the opposite. This tells you all about that. So far you've written traditional proofs where you have the two columns. You have your reasoning and you have your statements. So these are ones you're more familiar with. You've also written a coordinate proof where you had your if-then statement, you had your work, and then you had your therefore statement. But now we have an indirect proof. This is the shortest proof that you'll come across. So in an indirect proof, I'm reading right here, you begin by assuming that the conclusion is false. You kind of assume the opposite. So if I were to say that 1 plus 1 equals 2, an indirect proof would take that and assume the opposite and see if it's true. So the opposite of 1 plus 1 equals 2 is 1 plus 1 does not equal 2. Well, is that true? Does 1 plus 1 not equal 2 ever? No, not true. So since that's not true, since I can't really prove that wrong by assuming the opposite, I can assume that this is true. Okay, so it's kind of weird. You're assuming the opposite to prove that the original is true. I'll show you some other ways of doing this. So just remember, you're assuming the opposite. On your test is going to be the most basic thing. You just assume the opposite. So first of all, identify the conjecture to be proven. Assume the opposite of the conclusion. I've said the conclusion, not the given. The conclusion, what you're trying to prove, and use direct reasoning to show that it leads to a contradiction. So if I did this and 1 plus 1 did not equal 2, then that would be proving the original is not true. So let's say 1 plus 1 equaled 3, and I said, okay, it does not equal 2. Well, that would be true in that case. And so since the assumption is false, the original must be true. I'll show you in a different example. Okay, so write an indirect proof for this. So a is bigger than 0, therefore 1 over a is greater than 0. So we're going to ignore our given. We're ignoring it. We're trying to prove this. So in an indirect proof, we're going to assume the opposite. What is the opposite of 1 over a greater than 0? Well, 1 over a is less than or equal to 0. That would be the opposite. This is the opposite. Now let's see if that's actually true. We're just going to solve for a, essentially. Let's try to get a by itself. So we got 1 over a is less than or equal to 0. How do I get a out of the bottom? I'm going to multiply both sides by a. And see these a's cancel, and I have 1 is less than or equal to, well, 0 times a, anything times 0 is 0. So 1 is less than or equal to 0. Is that true? Is 1 less than or equal to 0? No, this is false. So since the opposite is false, the original must be true. Okay, so I can't prove it wrong in this case. And this shows you what I did. I can't prove it wrong, so therefore the original is true. Okay, so what you're taking in these indirect proofs is you take the opposite, try to see if it's true, and if it's false, then the original is true, because you can't prove it wrong. You're trying to make a counter example, essentially, is what you're trying to do. Let's do another one. This one's a little bit nicer. So given a triangle's interior angles add up to 180. We already know that. We know that a triangle adds up to 180. You got a triangle, all these angles add up to 180. Okay, we're trying to prove that a triangle cannot have two right angles. So we're going to take this and we're going to assume the opposite. What is the opposite of a triangle cannot have two right angles? A triangle can have two right angles. So let's see if a triangle can have two right angles. And already you might see that it's not possible, because if you have a right angle and then another right angle, can this be a triangle? Well, I mean, you might think to do this, but now that's a pentagon, isn't it? No, it can't have a triangle that way. But let's go down here for our beautiful little number thing. Okay, so 3 angles added up equals 180. This is a triangle. If 2 of those angles are 90, that doesn't leave much room for the last one, does it? Because you already have 180 here, and your triangle can only add up to 180. We can't have a zero triangle or zero angle. So the original must be true. A triangle cannot have two right angles. Or you could do this drawing here and say, hey, yeah, no, not happening. That would be a box. That can't be a triangle. You can't connect those. Okay, so moving on. So that's an indirect proof. Like I said, it's short and sweet. You're just assuming the opposite. That's all you're doing. It's going to be very basic on your test. Just assume the opposite. Okay, now let's talk about angle side relationships and triangles. So the bigger the angle, the bigger the side. Okay, remember that. The bigger the angle, the bigger the side. We're going to look at the side across from it. So angle C here, if you look across from it, that's the angle we're talking about it. So think of it this way. The more you open the door, so here's the door. That's it. Let's say this is the door right here. This is the door. And this is maybe the opening. So here's you walking through. Yay! I'm walking through the door. Okay. So the bigger the angle, the more you open the door, the bigger this gap is right here. So let's say you're carrying a very large box and you need to be able to fit through the door. So you'd probably have a bigger angle to be able to fit through the door, right? So the bigger the angle, the bigger that side. So angle C here across from it, that's a very big side. Now angle A on the other hand looks a little bit smaller, and so this side's going to be smaller. Okay, so these are just some theorems that we have. The bigger the angle, the bigger the side. The smaller the angle, the smaller the side. We're going to look at the opposite sides, and I'll show you real examples here. So we're going to write these angles in order. We only have the sides here. So our smallest side is right here. We're going to look at the angle across from it. So think of it as a door. So this door is not open as much. So angle F is my smallest angle. Okay, now we're going to look for our second smallest side. I'm going to erase this, which would be this. And so you look at the angle across from it, and that's the second biggest. And then the biggest angle would be across from the biggest side, which would be angle G. Okay, see how angle G is right here? So summary of that. So smallest side, smallest angle across from it. Biggest side, biggest angle across from it. So from smallest to greatest, you got angle F, angle H, angle G. We're just writing in order. So now let's do it in order of our sides. Ooh, okay. So we got 60, 72, we're missing a side, or an angle. So we know the whole thing is 180, so you can do 180 minus these two, and you should get 48, as it says right here. Okay, so find your missing angle, and you might have one similar to this on your test. So find the missing angle, and now we're going to list them in order from smallest to greatest. Smallest to greatest sides. So you look at the side across from it. This is the smallest angle, so it's going to be across from the smallest side. So QP is my smallest. Okay, now look for the medium-sized one. 60 is across from the medium-sized one, QR. And then my biggest is across from my biggest angle, PR. Oops. Okay, so then we have smallest, medium, largest. Okay, this one, we're looking at angles again. So we got smallest side across from the smallest angle, angle B. What's next? Angle A, and then my largest, angle C. Don't forget to write angles. These are not less than signs, they're angles. If you want to be traditional, they kind of look like that. Mine kind of just look like less than signs. Okay, and we're looking at this one again with the angles. We're going to write the sides. So you got 22, and this is a 90. And it looks like my last one's going to be 68. So if you don't know how to find that, the whole thing is 180. You subtract these two, and you should get your last little angle there. And then we're going to write in order from smallest to largest. So we got across from the 22 is EF. And don't forget this is 90. If you need to write 90 to help you, you can. Okay, next largest is DF. And then my largest is my hypotenuse. If you didn't realize this is a right triangle, the hypotenuse is always the largest, DE. Okay, now let's talk about whether or not things are actually a triangle. In order to have a triangle, the third side needs to be longer than the other two. So think of it this way. You've got 4, 4, and 7. Obviously, that's a triangle because it looks like a triangle, right? What's 4 plus 4? 8. 8 is bigger than 7. 4 plus 7, 11, is bigger than 4. Same thing here. Notice that if I add 2 of them together, it's bigger than the last one. Okay? That's a requirement in order to have a triangle. It needs to be bigger. Any 2 that you add up need to be bigger than the third. Now, looking at this one, you got 3 plus 3, 6. 6 is not bigger than 7. And if you were to draw this like this, you have 7. If I were to lay these flat, I'd have 3 and 3. And see, I can't connect these. It's impossible. Those sides are way too short. So in order for this to be a full triangle, these 2 need to be bigger than the last one. 3 plus 3 needs to be bigger than 7. So this would be like 3 and 5 would be acceptable. Now, what if it was 3 and 4? Now, 3 plus 4 is 7, right? And if I lay these flat, they're going to be a straight line on top of the 7. Let me redraw this. You got 7, you got 3, and you got 4. Does that make a triangle? No, it makes a straight line. So these 2 need to be bigger, not equal, need to be bigger than this last side. Otherwise, you don't have a triangle. You just have a line. So you either don't have something connecting or you just have a line. It needs to be bigger. And here is the traditional way of writing it. Okay, so they need to be bigger, not equal. They need to be bigger. So let's look at these. Let's see if this is a triangle. So we're going to take 2 of them and see if they're bigger than the third. So 7 plus 10 is 17. Is that 17 bigger than 19? No. And if we were to draw this out, we'd have 19 here. We'd have 7, and we'd have a 10, and they would not connect. They would not connect nicely. And let me draw that a little bit better. There you go. Okay, they would not connect. I can't have a triangle with that. That does not work. And you don't need to write all this if you don't want to. This can be your explanation. That's a wonderful explanation right there. Okay, let's see with this one. So we're going to take 2 of them and see if they're bigger than the third. And you're going to bundle these 3 different ways. So we took the first 2, 2.3 plus 3.1, and see if that's bigger than 4.6. And it was. Cool. Okay, and then we're going to take 2.3 and add that to 4.6 and see if that's bigger than 3.1. So I just bundled these 2. See if it's bigger than the third. And it was. And then my last one, these 2 added together, see if it's bigger than the third. And it is. So if all 3 inequalities work, if all 3 sides added together are bigger than the third side, then you have a triangle. And this would be your explanation. These right here. You don't need to write all this. Okay, your inequalities are your explanation. That's perfectly fine. Okay, now what if you have this situation? Well, anytime I see this, I know to plug in. So you're going to just plug in to everywhere you see n, and then do your inequalities again. Okay, so here you have 10, here you have 15, and here you have 12. So 10 plus 15 needs to be bigger than 12. 15 plus 12 needs to be bigger than 10. And which one did I not do? Oh, 12 plus 10 needs to be bigger than 15. And if all 3 of those work, then we have a triangle. So let's see here. So 25 is bigger than 12. Cool, okay. 27 is bigger than 10. Excellent. And 22 is bigger than 15. So is this a triangle? Yes, this is a triangle. Okay, and that's what they did here. Okay, same thing here. Just add them up. So these 2 need to be bigger than the third. And if you want to do the other ones first, you can. 13 plus 21 needs to be bigger than 8. Which one did they not do? Let's see. 21 plus 8 needs to be bigger than 13. Okay, so all 3 of these need to work. If one does not work, then it's a no-go. Okay, this triangle looks like this. That's a line. That doesn't work. Okay, same thing there. I'm not going to go through that one because we've already gone through it. Skipping around a little bit. Okay, here we go. So find the range of possible lengths for the third side. So this time they don't give us the third side. They just give us 2 sides. So we know that the third side is going to be x. So we have 8 plus x needs to be bigger than 13. X plus 13 needs to be bigger than 8. And 8 plus 13 needs to be bigger than x. And you just solve for x. And you should get 3 inequalities with x. Now this is kind of a weird part. We're going to throw out the negative. Anytime you have a negative, just throw it out. Your answer will be these two. Okay, I'll show you with another one. So we got 22 and 17. We're going to find the third one. So 22 plus 17 needs to be bigger than x. 17 plus x needs to be bigger than 22. And 22 plus x needs to be bigger than 17. And now we just solve for x. So what do we have here? 39 bigger than x. Okay. X is greater than 5. And x is greater than -5. So I see the negative, we're throwing him out. And this is my answer right here. And if you want to merge it together, you can. You just put x in the middle. Smaller number, bigger number, and it eats the bigger numbers. So x is bigger than 5, but smaller than 39. This would be a traditional answer. This is fine too. Okay, so what this tells me is my third side could be anywhere between 5 and 39. We could have a really big triangle with the 39. We could have a really small triangle with the 5, but it could be any number in between there. And this is just finding the range for all the possible lengths of that third side. Here's a word problem with the same type of thing. This time they have x right here, and you just do the same thing. You notice when we get our 3 things, you get a negative, you cross him out, and you just have your 2 things here. So in this instance, the range of distances from San Fran to Oakland, so it could be 5 miles, it could be 97 miles, somewhere in there. And you're just finding the possible range. Okay, and you can practice with these if you want, but good job, guys.